For this question, you need to be familiar with linear equations, midpoint theorem, and how perpendicular gradients are related. Okay, so the question states that ABCD is a quadrilateral, B lies on the x-axis, and that the diagonal BD bisects AC at right angles at M. Okay, so BD and AC, they are perpendicular lines. Okay, you need to find the equation of BD. So just a recap, BD is a straight line, so linear equations take the form y equals to mx plus c. Okay, M is the gradient, right? The gradient tells you how steep a line is. For example, if this line, okay, from point A to point B, right? To get to point A to from point A to point B, you move to the right by 5 units and you move up by 10 units. That would mean that the gradient is 2 because you take the rise over run. Rise is the vertical movement, run is the horizontal movement. You get 2. How do you interpret 2, right? Essentially, it just means for every unit you move to the right horizontally, you move up by 2 units. So that's the intuitive interpretation of what a gradient is. Okay, and then C is the y-intercept, right? Y-intercept. So for example, if you have a graph and then any graph cutting across the y-axis, right? This point where it cuts the y-axis, that's the y-intercept. Okay, so for a linear graph, right, like y equals to 3x plus 4. Okay, 4, this will tell you 4 is the y-intercept. Okay, so to find the equation of any line, right, you just need to know the gradient, okay, and a single point on the line. So if I have this line like that, I know that the gradient is 5, okay, and the coordinates of this point is maybe 3 comma 4, for example, right? I can begin to write out the equation already. Y equals to, the gradient is 5, right? 5x plus c. To find c, as long as I have a single point that lies on the line, right, I'll be able to solve for c. Because remember, the equation of the line tells you every single point that lies on this line. So if I know a single coordinate, like let's say for this point, if I know the value of x, right, I sub into the equation, I should be able to get the value of y, right? So if I know both points, then I'll just sub them into the equation, right? Like the x coordinate is 3. From the equation, I know that it should give me back 4 as the answer, right, for y. So if you look at this equation here, there's only one unknown left, and I can solve for it. 4 equals to 15 plus c, c equals to 4 minus 15, c is negative 11. So the equation of the line will be y equals to 5x minus 11. So with that in mind, we can try to figure out how to find the equation of BD, right? First, let's try to find the gradient of BD, okay? Gradient of BD. So we don't have enough information to find the gradient of BD directly, right? We don't have a single coordinate. So, but we do know that BD is perpendicular to AC, okay? So how are perpendicular gradients related? If we know the gradient of of AC, it we will be able to find the gradient of BD because the product of their gradients must be -1. Okay, this is an important rule that you need to know. Okay, perpendicular gradients when multiplied together will give you -1. And we can't find the gradient of AC, right? Because we have two coordinates here. Right? We just have to find the rise divided by the run. Okay, so yeah, we always look at it from left to right, right? So C is the leftmost point. When it moves to A, it goes down, right? So the rise is -2, right? Because you see the y coordinate here is 3, and then the y coordinate here is 1, right? To look at the vertical movement, you need to look at the y coordinates. So from 3 to 1, you move up by -2 units. You're moving down. Okay. Then the run, you look at the x coordinates, right? From 1 to 5, that's 5 units. So the gradient of AC is -2 over 5, right? So if we sub that into the equation, right? Gradient of AC times the gradient of BD must be -1, which means to find the gradient of BD, we divide both sides by -2 over 5. Okay, so -1 divided by -2 over 5 is just -1 times -5 over 2. Negative cancel out, right? So the gradient of BD is 5 over 2. Okay, we found the gradient of BD now. Now we need a single coordinate that lies on BD, right? So how do we find a single coordinate, right? One coordinate. Okay, there's no information about point D. For point B, we know that it lies on the x-axis, right? So the y coordinate is 0. Still not enough information. Okay, let's clean up the diagram. Okay, another point lies on BD, and that's M, right? Are we able to find M? Yes, you see, these two markings indicate that M is the midpoint of A and C, right? So we can use the midpoint theorem to find M. So what's the midpoint theorem? The midpoint theorem actually kind of uses similar triangles, right? Okay, see, if you draw a right angled triangle using A and C, and then you make another triangle with M, you realize that they must be similar triangles, right? And if M is the midpoint of A and C, that means the ratio is 1:2. Sorry, let me use, yep. So if the ratio is 1 unit is to 2 units on this side, then horizontally, the ratio should be the same as well, 1 unit to 2 units, right? Vertically, same, 1:2. Okay, so that would mean that the x coordinate of M lies exactly in the middle of the x coordinates of A and C, right? Which is why to find the x coordinate of M, you just take the average of the x coordinates of C and A. Okay, so if you sub that in, it's 1 plus 6 divided by 2, so you get 3.5. And then same thing for the y coordinate of M, right? You take the average of the y coordinates of A and C. So the y coordinate of C is 3, y coordinate of A is 1. Okay, so the coordinates of M is just 3.5, 2. Okay, so yeah, my workings got a little messy. I just tried to tidy it up a bit. Let me shift this up here, make it smaller. Okay, just one clarification on the midpoint theorem, right? Some people get confused. So, for example, if you want to find the middle of the y coordinates, right, in between, let's say, I mean, the middle of the x coordinates, so 1 and 6, right? Some people might take 6 minus 1 and then divide that by 2, right? Because the length is 5 units, right? So if you divide by 2, it's 2.5, right? But that's not the coordinate of M. That tells you the length of the horizontal distance from C to M. That's 2.5 units, right? The exact coordinate is 2.5 units to the right of X, which is 1. So you have to add 2.5 to 1. Okay? To think about it in a different way, right? If you want to find the middle of 6 and 7, 5 and 7, the middle is 6, right? You cannot take 7 minus 5 to have like 2, right? That is how far 6 is from 5. If you want to get the number 6, you need to add the endpoints 5 and 7 and find that average to get 6. Okay? So it's an addition, not a subtraction. Okay, so now back to the question, right? We have got a gradient and a single coordinate on the line. So to find the equation of PD, right, we can start with y equals to gradient, right, 5 over 2x plus c. Now we need to solve for c. We have a set of coordinates here, we can just substitute that in, right? We know that x should be 3.5, and the equation should tell us that y is 2 because that point lies on the line, right? So the equation should be able to solve for that. Okay, so if you solve for that, then you'll find that c must be negative 27 over 4. Okay, so you just rewrite the equation with your value of c written in, and this will be the answer for part 1. Okay, so now that we have the equation of line BD, then part 2 will be pretty easy because part 2 you're supposed to find the coordinates of B, right? Part 2. Okay, based on the diagram and the information given in the question, B lies on the x-axis. So if it lies on the x-axis, right, the y coordinate is 0, right? Because below the y-axis, right, y gets negative. Above the x-axis, or below the x-axis, y gets negative. Above the x-axis, y gets positive. So on the x-axis itself, the coordinate of y is 0. Okay, so we need to figure out y, right? So we can just substitute x equals to 0 into the coordinates because B lies on BD, right? So y equals to 5 over 2 times, y is the one that's 0, right? So sub y is 0 equals to 5 over 2x minus 27 over 4. And from here, we can solve for x. 5 over 2x equals to, so we add 27 over 4 on both sides. Okay, 5 over 2x equals to 27 over 4. Divide by 5 over 2 on both sides to find x. So 27 over 4 divided by 5 over 2 is 27 over 4 times 2 over 5. And that tells us that x is 27 over 10. Okay, so the coordinates of B is 27 over 10, comma 0. Okay, so finally for part 3, we are supposed to find the coordinates of D. Okay, so again, this question is actually making use of midpoint theorem, right? You can't sub anything into the equation of BD because we don't know a single coordinate for D, right? But there's this extra bit of information they give us. ABCD is a parallelogram. So, okay, one property of parallelograms, right? For rectangles, squares, and their slanted variants, right? So the slanted version of a of a rectangle is a parallelogram, and the slanted version of a square is a rhombus. So for all these figures, right, their diagonals will bisect each other. Okay, so yeah, essentially the diagonals will cut each other into half. All right, so M is not just the midpoint of A and C. M is also the midpoint of B and D. Okay, so remember the midpoint formula, right? To find M, you take the average of the x coordinates of, okay, to find the x coordinate of M, that would be the average of the x coordinate of B as well as the x coordinate of D. Okay, we have N, right? We found it earlier, 3.5, right? The x coordinate of M is 3.5. The x coordinate of B is 27/10. And we are trying to find the x coordinate of D, right? So if we make the x coordinate of D the subject, then we can solve for the x coordinate of D. So you times 2 on both sides, you get 7. Then after that, you just minus 27/D on both, 27/10 on both sides. So I think that would be 43/10. That's the x coordinate of D. Then yeah, we do the same for the y coordinate of D. Okay, the y coordinate of M will be the average of the y coordinate of B and the y coordinate of D. So sub in the values that we know, which is like 2 equals to 0 plus yd/2. Multiply by 2 on both sides. Okay, you get 4 equals to yd. So yd is just, the y coordinate of D is just 4. The coordinates of D will then be 43/10, comma 4. That's the final answer.